Very good morning, students. Unit 10 Chemical Bonding. Unit 10 Chemical Bonding. In this session, I am going to teach the introduction of chemical bonding, the Kossel-Lewis approach to chemical bonding, and the introduction of chemical bonding. The first one is there, the introduction of chemical bonding. Okay, the diamond is very hard. The diamond is very hard, while it's the electrographite. The electrographite is very soft, right? So the diamond is very hard, while it's the electrographite is very soft. The gaseous like chlorine, hydrogen, oxygens are diatomic, while the inert gases, the noble gases, helium, neon, argon, krypton, xenon and radons are monoatomic. Right? The gaseous like chlorine, hydrogen and oxygens are diatomic molecules, while the inert gases, noble gases like helium, neon, argon, krypton, xenon and radons are monoatomic. The carbon combines with chlorine to form carbon tetrachloride liquids. So the carbon tetrachloride liquid is insoluble in water. But sodium combine with chlorine to form sodium chloride. Okay, so carbon tetrachloride, 1 carbon, 4 chlorine. So 4 chlorine. Sodium chloride. Okay, so 2 chlorine, 2 sodium, 2. The sodium combines with chlorine to form sodium chloride. The sodium chloride is a hard and brittle crystalline compound. So hard and brittle crystalline compounds. So easily soluble in water. Okay, so both are chlorine. The chlorine combined with the carbon to form carbon tetrachloride. But carbon tetrachloride liquid does not dissolve in water. The chlorine combined with the sodium to form sodium chloride. So sodium chloride is easily soluble in water. Right? So the possible reason of these observations lies in the types of interaction exist between the atoms of these molecules. Right? So this interaction is responsible for holding the atoms or ions together. Right? So the interatomic attractive forces which hold the constituent atoms or ions together in a molecules are called chemical bonds. Right? The interatomic attractive The interatomic attractive forces which hold the constituents atoms or ions together in a molecules are called chemical bonding. The interatomic attractive forces. So Na plus Cl minus. So CCl4. The interatomic attractive forces. The interatomic attractive forces which hold the constituents atoms, carbon and chlorine is atoms, or ions, Na plus and Cl minus ions, hold the constituent atoms or ions together in a molecules are called chemical bonding. Okay students, so why do atoms combine only in the certain combination to form a molecules? Why do atoms combine only in certain combination to form a molecule? For example, the oxygen combines with hydrogen. The oxygen combines with the hydrogen to form water. So oxygen 2, hydrogen 4. So form water. While the oxygen combines with the carbon to form carbon dioxide. The ratio of oxygen in water is 1. So 2:1. The ratio of water in carbon dioxide 2, right? So 1:2. The structure of water is V shape. But in structure of carbon dioxide is linear. So structure of water is V-shaped and structure of carbon dioxide is linear. So such questions we can answer using the principle of chemical bonding. Okay, so in this unit we can analyze the various theories and principles which were developed over the year to explain the nature of chemical bonding. Okay students, the next one is the Kossel and Lewis approach to chemical bonding. Kossel and Lewis approach to chemical bonding. Chemical bonding, say a logical explanation. A logical explanation for chemical bonding was provided by Kossel and Lewis in 1960. Their approach to chemical bonding is based on the inertness of the noble gases. So which have little or no tendency to combine with other atoms, right? So the Kossel and Lewis approach to the chemical bonding is based on the inertness of the noble gases, right, which have little or no tendency to combine with other atoms. The noble gases helium, neon, argons are no tendency to combine with other atoms, but krypton and xenons are little tendency to combine with the other atoms. Okay, so the krypton and xenon reacts with highly electronegativity oxygen and fluorine, right, to give xenon difluoride, xenon tetrafluoride and xenon hexafluoride. Okay, so little or no tendency. The helium, neon, argons are no tendency to combine with other atoms, but on krypton or xenons are so low ionization energy having noble gases. Low ionization energy having noble gases, krypton and xenon. Okay, and high electronegativity elements, oxygen and fluorine. Are you right? So the low ionization energy having krypton and xenon combined with high electronegativity oxygen and fluorine to form compounds. Okay, so xenon difluoride, xenon tetrafluoride and xenon hexafluoride. Are you right? So the little or no tendency to combine with other atoms. Okay, so the Kossel and Lewis proposed that the noble gases are stable. The noble gases are stable due to the completely filled electronic configuration. For example, argon, right? So atomic number 18, 1s2, 2s2, 2p6, 3s2 and 3p6. The completely filled outermost electronic configuration, the common formula ns2 and np6. In argon 3s2, 3p6. Are you right? So the Kossel and Lewis have proposed that the noble gases are stable. Noble gases are stable due to the outermost completely filled electronic configuration. The outermost completely filled electronic configurations. The elements other than noble gases try to attain the stable or completely electronic configuration. Completely electronic configuration by losing or gaining or sharing of one or more electrons present in the outermost cell. Are you right? So for example, sodium. For example, sodium Na, atomic number 11. So sodium loss of one electron, Na plus, to give energy, ionization energy, loss of one electron. Okay, so sodium atom is converted into sodium ion, right? So electronic configuration of sodium atom 281. Now electronic configuration of sodium ion 2,8. And gain of one electron in chlorine atom, chlorine 17. Okay, 2, 8, 7. So gain of 1 electron to attain chloride ion. 2, 8, 8. Okay, so this energy is electron affinity. This energy is ionization energy. Are you right? So gain of electron, loss of electron. Are you right? So both ions are attained to near noble gas electronic configuration. Okay, so 2 plus 8, 10. So neon electronic configuration. The noble gas neon electronic configuration 2, 8, 8, 18 in near argon electronic configurations. Are you right? So both atoms Na plus and Cl minus combine to give sodium chloride compounds. Okay, the electrostatic attractive force occurs between the two ions, right? In electrostatic, the electrostatic attractive forces occurs between the two ions. Okay, so this attractive force are called chemical bond, right? Then specifically this bond is ionic bond or electrovalent bond. Electrovalent bond. Okay, so Kossel explain electrovalent bond or ionic bond. Electrovalent bond or ionic bond, and Lewis explain the covalent bond. Lewis explain covalent bond, right? So the Lewis proposed to attain the attainment of stable electronic configuration of the molecules such as diatomic molecules, nitrogen and oxygen and etc. The achievement of mutual sharing is achievement of mutual sharing. Mutual sharing of electrons, right? The mutual sharing of electrons. Are you right? So the Lewis introduced the simple scheme to represent the chemical bond. You right? The Lewis introduced the simple scheme to represent the chemical bond. The electron present in the outer cell of the atom. Right? In this scheme, the valence electron, for example, the valence electron is 5. The symbol of element, for example, the symbol of element is X, any one of the element. Okay, so X valence electron is 5. The valence electron of the element, represents the denote the single dot. Around the atoms. Okay, it's a Lewis dot structure. Are you right? Okay, so the mutual sharing of the Lewis nitrogen and oxygen is achieved mutual sharing of electrons. Are you right? So the Lewis introduced the simple scheme to represent the chemical bond in the electron presence in the outer cell of the atom is called Lewis dot structures. This scheme, the valence electrons of the element is denoted to single dot in around the elements. For example, nitrogen atomic number 7, 2, 5. The valence electron is 5. The valence cell having 5 electrons. So valence electron is 5. Are you right? The first 4 electrons denoted in single dot around the element symbol. Are you right? The first 4 electrons denote the single dot around the symbol of elements. Okay. In fifth ambers, the electrons pass. Electron represents the pass. Are you right? So the Lewis dot structure of nitrogen N. Okay. So 2 pair electrons, 3 unpaired electrons. Are you right? Next, the dot structure of carbon. Lewis dot structure of carbon. Atomic number 6. 2, 4. Electronic configuration 1s2, 2s2, 2p2. Right? The valence cell, second cell. So having 4 electrons. So valence electron is 4. The Lewis dot structure carbon. Okay. The 4 electrons are denoted to single dot in 4 directions. Right? The next, oxygen. Right? So oxygen O, atomic number 8, 1s2, 2s2, 2p4. Right? The valence cell having 6 electrons. 2, 6. Okay? So the symbol oxygen O. The first 4 electrons, so denoted single dot in 4 direction of the symbol. Okay, other 2 electrons are paired. Okay, so the electronic dot structure, the Lewis dot structure of oxygen, right? Okay, students, the next one is the Lewis dot structure of helium. Okay, the helium having only 2 electrons. The 2 electrons having atoms. The 2 electron, only 2 electron having atoms. So represent as pair of electron dots. The pair of electron dots. So duet. It's a duet structure. Okay, so the other atoms having single 4 electrons, single dot electrons first. Okay, then pair of, right? But helium having the pair of dot structure. So duet. You right? The gases. The noble gases helium, neon, argon, krypton, xenon and radon having the 8 electron in outermost cell, except helium having 2 electron. Okay, in other noble gases having 8 electron in valence cell, right? So all the noble gases having 8 electron in outermost cell. In outermost cell having 8 electron, right? Okay, so obey acted rule. So more stable. The elements other than noble gases, so try to attain acted rule by losing or gaining or sharing of electron. For example, sodium Na11. Loss of 1 electron, Na plus 2, 8, 1 in atom, but ions 2, 8. So obey acted rule. Fluorine 17, 2, 8, 7. So gain of 1 electron, right? To attain chloride ion 2, 8, 8. The outermost cell having 8 electrons. So obey acted rule. Are you right? But in helium obey tubelet rule. The helium obey tubelet rule. The two electron having elements or molecules obey tubelet rule. For example, hydrogen. For example, hydrogen H2. The hydrogen having only one electron in each atom. Okay, so the both atoms mutual sharing of electron. Right? So hydrogen molecules having two electrons obey tubelet rule. Tubelet rule. Obey tubelet rule is more stable. Okay, so to reach the noble gas helium electronic configuration and lithium 3, right? 2, 1 in loss of one electron to reach lithium plus 2. So having two electrons obey tubelet rule. Obey tubelet rule is more stable. Okay, so to attain helium electronic configuration. Okay, so define octet rule. Define octet rule. The atoms share or transfer the atoms transfer or share electrons. So that all atoms involved in chemical bonding. Obtain 8 electrons. 8 electrons in the outer cell. In the outer cell or valence cell. Okay? The atom transfer or share. Right? The sodium Na plus loss of electron. Transfer of electron. So one electron is transferred to chlorine atom. In sharing of atom. The sharing of atom oxygen. In other one oxygen molecules. Okay, in one oxygen having 6 valence electron, 1, 2, 3, 4, 5 and 6. 2 paired electron, 2 unpaired electron, right? In another one oxygen having 1, 2, 3, 4, 5, 6. 2 paired electrons and 2 unpaired electrons. The 2 unpaired electrons are mutual sharing with both oxygen atoms, right? So the unshared electrons. Okay, in unpaired electron, mutual sharing between the 2 oxygen atoms. Okay, so other 2 paired. Obey octet rule. So 2, 4, 6, 8. Obey octet rule. 2, 4, 6, 8. The atoms transfer or share electrons. So that all atoms involved in chemical bonding. Attain 8 electrons. In the outer cell. Okay, students. Thank you, students. We'll meet next class. Right?